Hi guys, welcome back to YouTube channel Chemistry Lab UGPG. So today we will discuss hyperconjugation. So this is in accordance with NEP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So let's discuss hyperconjugation. So what is hyperconjugation? So when C double bond C or carbon-carbon double bond is attached to the carbon atom containing alpha hydrogen atom, then there is release of CH electrons, carbon hydrogen electrons to the carbon carbon bond to form a pi bond, and instantaneously the transfer of pi bond electrons of carbon carbon double bond takes place, causing polarization of carbon carbon double bond. This effect is known as hyperconjugation. So let's discuss once again. So when carbon-carbon double bond is attached to the carbon atom containing alpha hydrogen atom, okay, then in that case there is release of this carbon hydrogen electrons to the carbon-carbon bond to form a pi bond, and instantaneously the transfer of a pi bond electrons to the carbon-carbon double bond takes place, causing polarization of this carbon-carbon double bond. So this effect is known as hyperconjugation. So if we take one example, that would be more clear. So here this is the carbon-carbon double bond, and that is connected to the carbon which is alpha carbon atom, and that hydrogen attached to this carbon is alpha hydrogen atom. So what happens here? This alpha CH alpha hydrogen CH bond will transfer its electron to the C single bond C, and the polarization of this carbon-carbon double bond takes place. So as a result, you generate a carbanion here, and this loss of this hydrogen giving rise to H plus. So similarly, this hydrogen also do the same thing. You generate the structure here again. This hydrogen loss can give rise to this structure. So this effect or this polarization effect is called hyperconjugation. So more is the number of alpha hydrogen atoms, so more will be the number of hyperconjugative structures, and hence more is the stability of the compound. So these hyperconjugative structures will improve the stability of the compound. More the hyperconjugative structures, more is the stability of the compound. So here in this structure, so here carbon-carbon double bond, it is attached to the carbon containing alpha hydrogen atom. So here you have a 3 alpha hydrogen atom. Here you have only 2 alpha hydrogen atom. And here you have only 1 alpha hydrogen atom. And in this structure you have a 0 alpha hydrogen atom. So the order of stability will be 3 alpha hydrogen atom will be more stable than this structure, than this structure, than this structure. So as you can see here, this carbon hydrogen sigma bond will move here, and this pi bond will move here or polarize here. So as a result, you get this structure A. So this is a type of resonance or delocalization which shows the overlap between a sigma orbital of a CH bond and the p orbital of the carbon-carbon double bond. So as you can see, in the structure A, no proper bond exists between the carbon and hydrogen atom. So this carbon and this hydrogen has no, this proton has no bond exist, no proper bond exists. So hyperconjugation, that's why it is called no bond resonance. So let's talk about the application of hyperconjugation. So if you look at the dipole moment of formaldehyde, it is 2.27 dBi, and acetaldehyde is 2.72 dBi. So the hyperconjugation can explain the dipole moment of for a higher value for acetaldehyde. So as you can see here, formaldehyde will, so CO bond will break on oxygen, so you get C plus and O minus. And in case of acetaldehyde, you will have hyperconjugative structures. So here, with respect to C double bond O, this is alpha carbon atom, you have 3 alpha hydrogen atom. So loss of this hydrogen will give rise to this structure. Then this hydrogen loss will give rise to this structure, and this hydrogen loss will give rise to this structure. So more is the hyperconjugative structures lead to the higher dipole moment value. So there is more charge separation. So due to the alpha hydrogen atom. So the dipole moment value is high in case of acetaldehyde 2.72. So here the charge separation is large. So in acetaldehyde, due to hyperconjugation effect, the distance between opposite charges increases and thus dipole moment increases. Then next is stability of alkyl carbocation. So here this is tertiary carbocation, this is secondary, and this is primary carbocation. So as the number of alpha hydrogen atoms increases, the number of hyperconjugative structures increases. Hence the stability of the carbocation increases. So please subscribe to our channel Chemistry Live UGPG. So for class 11th and 12th, so this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.